Okay, we're going to get started now. My name is Javier Delgadillo, and this here is Ming Zhao. If you were here earlier, he just gave a presentation on how to create custom connectors for GeoEvent. I'm now going to switch over and talk about how to create custom processors for GeoEvent. So a quick agenda about what we're going to cover in this talk. First off, we're just going to give a quick overview of GeoEvent for the people who weren't here before. For those of you who were, I'm sorry, it's going to be a bit of a review, but we feel compelled to give this every time we talk about GeoEvent. And then I'm going to jump into a real quick demo showing a custom processor that's already working. So you can see how once it's deployed, it's not much different from an out-of-the-box connector. And just show how we can use it in stream services and all the other stuff that GeoEvent is already doing. And then once we see it in action, we'll go sort of take the deep dive to show the life cycle, all the different code that you have to write to do it, and the various screenshots that show what the code is actually doing. And once we get that part, I'll give you guys a treat and actually show you how you can attach your debugger so you can single step through your code and troubleshoot what's going on, because even though we're all good developers, sometimes you actually have to step through and debug and figure out why the hell isn't this thing working. And then we'll conclude with questions just like every other talk. So first off, here's the review of sort of real-time GIS at 10.5. The GeoEvent server gives ArcGIS server the additional ability to integrate real data into the ArcGIS ecosystem. So before GeoEvent, really the only things you could visualize on a map was stuff that was already in a geodatabase file or already in a map service. If you had some data out there that had geography location in it, it was really difficult to get it in an easy way. You sort of had to sit there with ArcMap and paint and manually edit everything and add all the entries, and that was the only way to get it in any sort of map, whether it was server or ArcMap. So now when we came with GeoEvent, now we can sort of say, okay, we've got this sort of standard data format, whether it's RSS, JSON, CSV file. Stuff that we can quickly and repetitively sort of parse and update and send it and bring it into the GeoEvent, the ArcGIS ecosystem, and now we can visualize it. So example of things that you can do there is like you can bring in user-generated content like RSS feeds like we were talking about earlier. We have connectors to bring in Instagram or Twitter. So now you can sort of get dynamic content out from the world and bring it into the GeoEvent and ArcGIS and visualize it along with all your other data. And there's also public feeds out there you can bring in. You know, there's the air traffic FAA feeds you might have access to that you want to visualize. There's maritime information about boats. There's also stuff about bus routes and things of that nature that you might want to just put up on a website quickly without having to sort of have a manual process of reading data, copying it in, and then publishing so that you can see it on a map. And once you get that data in, not only can you visualize, you can actually look at it and now analyze it. So you can see, is my bus getting close to where I am right now? And if you've got a web app on a map, you can actually start walking because your bus is getting close by. Or, is traffic really bad right now? Things of that nature. Things that we sort of take for granted now that are happening on lots of websites, technologies like GeoEvent sort of enable that stuff to happen much more seamlessly into the GeoEvent infrastructure. And then once you've done your analysis on all this data, you can now sort of send updates to something. You can update a map, you can send an email, SMS alert, and if you were here for the connector thing, you can write your own connector and spam whoever you want after you've finished your analysis of all the information that is coming through. So let's take a quick look at the connectors that we just went over in this last talk. So out of the box, we have input connectors that can receive or pull data in like RSS, text, JSON, or feature JSON formats. And you can actually pair them together with different types of transports like a TCP or UDP socket or a REST endpoint, right? And if you have more current server technology, you can even connect it to a WebSocket, right? So that the WebSocket is actually pushing data to you and you're not having to pull for it anymore. So that's really helpful. In addition to these out-of-the-box collectors, we also have a gallery that you can go up and sort of see what's there and sort of play with those, install those, and configure those. So like Ming mentioned before, be sure that before you go and start developing your own connectors or processors for that matter, you go to the gallery and see if something exists that you might be able to use without having to write any code. And then just another quick review of the connectors. Every connector is really just a pairing of two existing components inside of GeoEvent, the adapter and the transport. You can choose to couple two together, one from the gallery and one from that out of the box. Like in this example right here, we highlight the Kafka transport, which is available on the gallery now. And you can couple that with the feature JSON adapter. So you can write feature JSON to a Kafka hub. That's not something that's available out of the box, but using the UI and without writing any Java code, you can do that as well. Or you can decide, or you can notice that I just need to have GeoJSON. I need to go fetch GeoJSON from an HTTP server, and that connector just doesn't exist out of the box right now. So I'll go ahead and create that. So that's quick ways of sort of adding the ability, giving GeoEvent the ability to ingest other types of data that it doesn't have available out of the box. Let's moving on. All right. So then let's move to the output side. When you disseminate the data, just like on the input side, we have a bunch of connectors that are available out of the box and some that are available in the gallery. So you'll see that we now have the Amazon IoT connector and an Azure IoT connector. Those are pretty new, so those of you who are out playing with IoT devices like the one Ming is playing, if you've hooked them up to Amazon or Azure IoT, you can now go download this connector, install it at GeoEvent, and start playing with the hub that way. That's another thing we've sort of been experimenting with, sort of using the existing IoT hubs as sort of the gateway that for high availability for GeoEvent. So you put the hub in front of GeoEvent, and instead of deploying your own, you can just use the Azure IoT, Amazon IoT, and see how that works, so that you're not having to manage your own message bus. Okay, why isn't that broken anymore? All right, and then just like on the input side, we can pair an adapter with a transport, whether it's out of the box or it's from the gallery. So in this, for this first example, I just want, out of the box, we have a connector where you can send an email. It's pairing the message formatter adapter with the SMTP transport. So the message formatter is an adapter that lets you just take attributes outside of from the GeoEvent and paste them into a boilerplate message, and then you can sort of send that out as an email from GeoEvent. I think recently we fixed it so you can send HTML email as well. I don't know if that's a good feature or not, but you can do that. You can do that now. And then just like we did on the input side here, we want to couple the Kafka transport with the feature JSON adapter. So now you can put feature JSON on a Kafka exchange, and you can go write clients that will read it off of there instead of if that's a use case that you have. All right, so now let's talk about the processors and the different type of processors we have. We have several geometry processors available to you now. So what we did, I think this was at about 10.4, we took the Esri Java geometry libraries and we basically wrapped every function that they gave into a processor. So you'll see all of these over here on the left-hand side. No, well, not all of them. The creator, the convex hull creator, all of these that sound like geometry operations, they basically just wrap existing geometry Java APIs and let you do those operations on the geometries of the GeoEvent that are passing through your service. So in the example we're going to do later today, I'm actually going to use the buffer creator processor to create a buffer around a point, and then we're going to do something with that. And convex hull creators and difference creators and envelope creators, right? So all these things. So now you can choose to either replace the geometry of the event that's coming through. So each event will have its own geometry associated with it. And after you run this processor, you can replace that geometry or just add it into a new field. And that really depends on what you want to do. Sometimes you just want to replace the geometry so that you can update a feature service that's doing something, or you just want to calculate something down the line in your service using the updated geometry. We also have processors that enrich existing events. So you can, the most common use case of this is for like static sensors. You'll have sensors out in the field whose geometry never changes. It's always in the same point. It's always the same X and Y, but the readings it's giving out are different. So what people will do is they'll have a feature service that has basically a track ID in the feature service that matches a unique identifier with the sensor. And then the processor will sort of join the attributes that are coming from the sensor with the fields that are in the feature service. And now you've got an event that has all the latest measurements and your geometry and whatever other metadata is in the feature service that never changes. And then now once you've got that in the event, you can, down the line, you can update another feature service or whatnot. So that's just sort of just taking a smaller event and making it a bigger event. And then the opposite is also true. We have a field reducer processor. So sometimes you get a lot of data coming in from your source, but you only want a small portion of that. So you can take that and reduce it down, and then you go and then you update the feature service you want or whatever it is you're trying to do. And I guess going back to the enricher, the sort of field mapper sort of falls into that. The field mapper sort of is, it's sort of I guess it creates a new, that one it creates a new event. So the field mapper will take an incoming schema or GeoEvent definition and sort of say this field A in GeoEvent A corresponds to field B in GeoEvent B. And so what it outputs is actually the GeoEvent B with all the mapped attributes. So now it's a good way to take one GeoEvent schema coming in and map it to the outgoing feature service that you want when you use that. And then finally, we have asynchronous processors. So these are a little tricky in that they'll get an event, but they're not going to emit an event immediately afterwards. So most processors, you get an event, you do something to it, and then you emit another event. For these processors, like the track idle detector that's on the gallery, it'll get an event and then sort of remember, okay, for this track, I got an observation at time Y. And for that processor, it's sort of configured to say, send an event if you don't get an update from track Y in 5 minutes. So it's got a little thread that sort of keeps going and says, all right, when was the last time I saw something from track A? And if it hasn't seen something in 5 minutes, it'll emit another event. But that's asynchronous. It happened asynchronously. It didn't happen when an event was coming through. So these are all the different types of processors we have in the system. I think there are samples on the gallery for each one of these. So if you have a use case that sort of matches one of these types, we recommend you go to the gallery and sort of download one and start from there and then move forward with whatever, and then let us know whatever issues you have and we'll help you. All right. So these are the sort of the components. These black boxes are sort of where you can extend GeoEvent, right? So we have the connectors on the input and the output side, and also the processors. For the rest of this talk, we're going to concentrate on the processors and what you can do there, how you can extend GeoEvent to fit your use case if the out-of-the-box functionality doesn't give you what you need. All right. So let's see what we have to do to create a processor. So we're going to go, this is a little quick diagram of the things we're going to show on this demo right now. All right. So before the session, I went out and downloaded the source code for this this processor that's out on GitHub. So this is the extent enricher for GeoEvent. Basically, what it does is when you get an event in, it'll figure out the envelope for that geometry of that event, and then add add these attributes to the new event. So it basically enriches the event that's coming in. It takes the event schema that you've got in, adds those 4 fields to it, and then emits another event with that. And so what I'm going to do is I'm going to take those fields that it calculates and create a link that I store in a stream service, and then the stream service will come up and it'll show. Then I can click on the link and it'll center the map right around where that feature was that was just coming through. So after you compile the code and you upload it using, just like in transports, you come to the component section of the GeoEvent Manager and you say you add a local processor, you select the jar file, you click OK, and then when things load, it'll show up right here. Right. And if you take a note of these strings right here, Ming was talking earlier about how you can localize these strings, but these are the strings that are coming from your service. So I just wanted to point that out so you can sort of make a visual map of what happens in the UI to what's going on in the code. But this is another place that it shows up, and this is just for the service itself. So let's go back and take a look at our service real fast. So what I've got here is I've just got a TCP text in. I'm simulating flight data using the simulator running on this VM. And what it's going to do, it's going to send it into a create buffer operator. And this is an out-of-the-box operator. And as you can see from this pop-up, I've told it to create a 500 kilometer buffer around the point. And it's going to replace the geometry in the event that comes out. So I'm no longer going to have the point that came in from the event. Now I'm going to have a buffer that's 500 kilometers around the point. And then it's going to send it to the extent creator, which is the processor I just installed. All right, so you can see right here, I just named it extent creator. I can select it from any one of these. All the rest that you show up in this list are out of the box. And they sort of fall into the categories that I was talking about earlier. But for this example, I selected the extent enricher. And I don't really care about the center point, so I said don't give me the center point as one of the fields you add to the event. That's another option you can have. And then what I did with that, I send its output to one stream service that just sort of has the event with the buffer ring in it. And then I also send that event to this guy over here, which is a field calculator. And what you'll see here is I'm telling it to generate this URL on the fly. And the interesting part here is I'm taking the min-x, min-y, max-y, max-x, and max-y, and putting them into the URL and adding that as another attribute in the event that's going through the service. And then that's going to go to this different stream service output that just expects the event to have that link attribute as part of its schema. So the only difference between this guy and this output and this output is this one is going to have a link as one of its attributes that show up in the pop-up. The other one won't. So now let's come over here and start the simulator. So now if I come here, first I'm going to open this in the JavaScript viewer. Because when you open this in the JavaScript viewer and you click on the link, it doesn't do anything special. But you can see right here, I can have the map viewer URL. It generated this big long string and it actually pasted in, substituted in the extent parameters that were generated by the buffer by the extent enricher processor. But if I then now go ahead and view it in the ArcGIS Online Map Viewer, I will get a map viewer that when I click on the object, at the very bottom I get this more info, which is a link. And when I click on that guy, I'm actually going to get another map That opens up centered around the, but I waited too long. The simulator replaced the dot. The simulator moved the buffer around, but you see there, I took a custom processor, I brought it into GeoEvent, I stuck it into a service, and now I'm operating, creating dynamic URLs based on output from that custom processor. So now let's go back and see how all of this works. All right. So first off, we got to remember GeoEvent is a Java-based product. So if you want to extend it, you're going to have to write some Java code. All of our sample projects and all of our code base is uses the Maven infrastructure. So now, along with learning some Java, I would recommend you study up a little bit on Maven and how that works. And then once you feel comfortable with that, sort of taking a sample project and then copying and modifying until it works is a pretty good strategy. But before we go that far, I mean, I'll remind you of the content that Ming showed in his talk, but when you install GeoEvent, you have the option of including the SDK. So you can choose to not install the SDK, but it doesn't take up that much disk space, so I recommend you leave it in there. But when you open up the installation directory for GeoEvent, you'll see these 4 folders. The API folder is a Java doc representation of the APIs you have accessible to you as part of GeoEvent. So we've taken some of the core libraries that we use to build the components, and we've labeled them as sort of core API stuff that we give access to everyone, and we publish those on and we actually publish those on the Maven repo, so you can just go ahead and start coding sample projects without having GeoEvent installed or without having access to this directory of the installation folder. But that API folder will give you the Java doc that you'll need to more effectively code against GeoEvent. And this repository folder, like we said, we are a Maven-based project, so we ship a very minimal Maven repo that has our jars in there, so that if you have to code offline, you can just you can use that repository to build. And I believe, correct me if I'm wrong, I believe our samples sort of use that as their repo to start off with. So unless you modify them, you'll be using that repo to sort of get the jar files. So that means you'll be coding with with whichever version of GeoEvent you have installed. And then we have another samples directory, which has a bunch of very rudimentary, very simple samples. It's just like an adapter that says, "Yay, I parsed my input," and generates a very simple GeoEvent, just so you can see how stuff works, and transports as well. And I believe there's a sample of an asynchronous processor in there as well, if you want to do that, because I know a lot of people want to come and ask, "Can I do this?" And it's basically an asynchronous process, and then we say, "Yeah, you have to sort of follow that example." And then lastly is the developer guide in there. There's a lot more detail about the APIs and more sort of a user-readable format, and not like the Java doc, which is very developer-centric. And it also has tips on sort of the framework that GeoEvent runs under that lets you sort of connect to the environment and do some basic operations. We try not to scare you too much, but we run something called OSGI for GeoEvent, and OSGI sort of, if you know it well enough, you can get in there. It has a shell, kind of like a Unix-like shell, and you can sort of do a lot of manipulations. If you ever get that far, you can use that as well. But yeah, once we got GeoEvent up and running, I hardly had to ever go in that shell anymore. So, but it's there if you need it. I hope you won't have to go that route. All right, so now let's go looking at the GeoEvent processor lifecycle. So first thing that happens is the user will submit a request to publish or start a new service using the GeoEvent Service Designer or web application. That was sort of the little piece we saw before where I showed there's like the graphs pointing to each other. The one node points to another. And the user will hit sort of start there or publish there. And then when that happens, GeoEvent looks up the processor service and the internal registry of ready-to-use components using some of the identifying metadata to make sure we've got the right one. And when we got the right one, we instantiate it, and then we're going to pass all of the user-specified settings to it so that the processor can initialize its internal state. And then once you've got all your internal state set up, we're going to say, we're going to call the validation method. So we're going to say, okay, you've got all your properties, you've got your internal members configured. So now tell us if all these properties of the user set make sense. If you need to access a file, make sure that file exists as part of your validation. If you need to hit a host and the host is unreachable, you might want to do that and validate, but that's something you might also want to defer until you actually start processing those events, because the server may be down when you initialize, but it may be up when you actually get an event. So it's more important, in that case, it's more important to error out as I get the event and the resource I need is unavailable. And so once you pass the validation, you're ready to process. And as events come through and they go through your service, you're going to get called once per event. At this version, we only support one. We only give you one event. And if you know the internal plumbings of GeoEvent and you ask us enough questions on the forums, we'll tell you how you can emit multiple events. Sort of the async methodology, that lets you emit something later, can also be used to sort of emit multiple events. So now you can get one in and send n out, where the API is sort of designed for one in, one out. If you know the plumbing and you ask us, like I said, we'll help you get multiple out as well. So now once you, the next thing that's going to happen is the user will sort of hit the stop button, because for whatever reason, either they edited the service or they don't want the service to run anymore, the stop method is going to get called. And now your shutdown method will be called after that. And in this case, this is where you sort of free up all of your resources. So if you had a connection to a server, a long-standing connection, you would sort of close that connection. If you were listening on a socket for whatever reason, I guess this applies more to transports and processors, but you would sort of close the socket, free up any memory maps you were using, things of that nature. Because remember, we don't restrict what you can do with your processor. So if you have a memory leak, and you're eating up all the memory, your processor will bring down GeoEvent, unfortunately. So be very careful when you're developing processors or transports that you do not have memory leaks. Because you'll bring down the whole server. Mm-hmm.
Good question there, though.
Uh-huh.
Doesn't the Java virtual machine help with that, preventing that?
Yeah, but if you've got a map that's just always growing and you're never removing entries from the map, you'll exhaust the RAM associated with the JRE, and then you'll start getting out of memory exceptions. And then that's it, you can't process anything after that. That's the most common one. So then after the shutdown, all your state goes away. And then we move on. All right, so now let's go a little bit further deep down into the code. What you'll find with GeoEvent, if you do any custom coding, the transports, adapters, and processors sort of follow a similar paradigm, where we have sort of a service/factory that gives us the definition for that component, in this case processors, and knows how to instantiate those components. It's exact same thing here with the processors. I've got the processor service, I've got the processor definition. And the processor definition is a collection of metadata. My service name, my service description, which are those 2 entries we saw in the UI just a bit earlier. It's also going to have a collection of GeoEvent definitions that I want to register with the system. So for example, the incident detector processor that's out of the box, when it emits an event, it events an event of type incident. So what it did, when we registered that out-of-the-box component, it said, I have the incident GeoEvent definition that I want to register with the system. So that exact same mechanism is available to you when you write a custom processor. Yes?
Are the events fixed, or can your application develop a new event type?
So the ones that are registered by you, originally it was a free-for-all and anyone could edit whatever you wanted, but we found that that caused a lot of support nightmares. So what we did later on, we have what are called core GeoEvent definitions, and so those are not editable. So it's up to your processor to mark it as non-editable or editable, but anyone can copy an existing GeoEvent definition and modify it however they want. And okay, and then so we just talked about the processor definition. So now the processor server, it knows how to create the processor itself. So it knows how to instantiate it, pass whatever information it needs to run, whatever internal things it needs to run. So if it has internal member variables that are services of the GeoEvent infrastructure, like the HTTP client service we have, or the GeoEvent definition manager service, which are other services that are available to you as part of the API. You can sort of, if they're available in your server, in your processor service project, you can set them to your processor when you instantiate it. And then finally, we have the configuration, which Ming alluded to in his talk, which is an XML file that basically tells GeoEvent framework how to instantiate your class, what properties to set on your class, and then what service you want to publish to the GeoEvent framework so that GeoEvent framework can listen and then sort of call your class and register it with the framework. All right. So now we're going to go over what GeoEvent server does to create your processor. First, you're going to create a Java class that implements the GeoEvent processor service interface, and this is something that's available inside of our JPI, inside of our SDK. And what we recommend is that you use this base class called GeoEvent processor service base, just because this is going to have a lot of the boilerplate code that you need your processor to work inside of GeoEvent. Out-of-the-box processor use this class, so we recommend that you use it because it'll be the quickest way for you to get all the functionality without having to write a lot of boilerplate code that may or may not be buggy. Next thing we see here is that every service is responsible for its definition. So in this case, I use the Java methodology of creating the definition. In Ming's example, he showed us a couple of ways of doing it where you can have an XML file to create the definition, but in this sample processor, we're just using Java, quick Java to create all the elements. And so you see here, part of the constructor just creates that definition, and that definition member is actually coming from the base class, which is wired to sort of use it to send it back to GeoEvent when GeoEvent wants to know what your definition is. Because if you remember back to the lifecycle, we said the service has to provide a definition. So this is where we're plugging that in. And then the last thing we see here is we've got the create method, which knows how to create the processor. And you'll also notice that it's calling the set messaging on the instantiated processor, the enricher processor here. And messaging is sort of one of those internal classes, internal services to GeoEvent that knows how to take an event and send it on down the graph. So when you have your flow of events inside of your service, the messaging service is the one that knows how to take the event that was emitted by processor A and send it on down to the next guy that's supposed to get it. All right. So now let's take another look at the processor definition. Ultimately, this class is responsible for providing the collection of properties your processor needs to run along with some of the metadata. You can see in the constructor that there is a member property definitions where you can put as many properties as you'd like. This will eventually show up in the UI and allow the user to make those settings when it's configuring a service. And the other thing to notice here is the bundle logger class. This is our internal sort of logger class that allows you to localize your messages and knows how to sort of get to those localized strings that Ming was referencing in his earlier talk. If we look at the second little screenshot on this window, we'll see that the property definitions member, which is another one that's coming from the base class, has the GeoEvent definition name. This is the programmatic key that we sort of use to look up your properties inside of the processor and all the components. So that's something you definitely will never ever want to localize. So I just wanted to point that out really quickly. We'll see here that that there's a bunch of parameters you pass to the construction and property definition. When you're using the XML-based stuff, it knows how to interpret those. But let me take a quick sidetrack to remind you guys how the localization stuff works with a bundle logger. As we've been talking before, we're using Maven extensively throughout GeoEvent. So if you want to, and when you want to create localized properties, you've got to pay attention to what your group ID and your artifact ID and your pom.xml file for Maven. And then you're going to create a file under the package group ID and then name it artifactid.properties. All right. And then what's going to happen, you can put in some of these methods that are available to you, you can put the whole fully qualified entry to get to the property file inside of that string, and then when we're sending the info back to the ArcGIS GeoEvent manager, we'll translate that string for you. So right, in this case, the label, that's the fully qualified name for the label. And then in the project, we sort of have, you can see the Esri GeoEvent processor package. And here we've got the extent enriched properties processor properties file. And in the property file itself, we've got processor label with a that says geometry extent enriched processor. And that is the string that we wound up seeing in the UI a little while ago. In the get label example, we had the fully qualified key, but if you've got a handle to the logger like we did in the previous file, you can just call logger.translate and pass it in the key. So there's no need to have the fully qualified name there. All right, and then just to show you guys all the things that you can do on a property definition, these are all at just a quick review for those of you who weren't here in the previous class, right? Every class has a name. This is the thing you don't localize. This is the programmatic key for access to the property definition. We have the types, so you can have like a string, a long, an ArcGIS data store. For those of you, if you have when you have one of the, like a feature enricher that wants to talk to a data store, you can say this property has to be a data store. Then the UI will show you. When it comes to that process, it'll just have a drop down of all the ArcGIS data stores that are configured, and you can pick one that way. The label is something you would want to localize, the description as well. Boolean mandatory means does the user have to set this or not? Is something that they can choose to ignore. Then there's the read-only. These properties are just ones you don't want the user to touch. For example, it could be, let's see, if you're running an HTTP transport and you want server or client mode, some of those you want to set in the connector and then not let the user touch it anymore. And then the last one is the allowed values. So sometimes it's you have certain protocols or certain archiving methods you want to use, and you just only support these three, so you're going to put the allowed values in that. And so that when the UI is asking the user to configure that property, it's going to have a drop down, and it's only going to allow them to choose one of those three. Okay. So now let's look at the actual processor definition and the code that is in there. So these are sort of the three identifying attributes of any processor or component. We're going to have the name, we're going to have the domain, and we're going to have the version. So using those three things, GeoEvent will uniquely identify your component. The one caveat we tell you is do not use com.esri.js to start off your domain, because if you do, we will assume you're an out-of-the-box component, and we will do weird things to your configuration when people start to use you in any service or input or output. So please keep that in mind. And then let's look at the other things in the processor definition. So these two on the top are sort of what go into the UI. In that list I showed you earlier where we had the name and the label, that's where these come from. The get contact info, we have it in there just in case you're gonna go to the REST API, because if you have a REST API, we will dump all this stuff in JSON format for you, and then you can do whatever you want with it. But as far as I know, I don't think the manager shows that anywhere. So this is really it's there for people who want to write so that people who write their own custom applications using our admin API can do something with it. And then I just put this last one down here at the end, because the sample processor that I'm using doesn't override it since it doesn't register any new GeoEvent definitions. It just augments existing ones. But this is the method you sort of implement if you want to register your own. You have this map. You just return a map of name to GeoEvent mappings. Okay, so now let's look at the methods that implement the lifecycle of the processor. Like first of all, like all the other cases we've been talking about, we have a base class that gives you all the functionality, all that boilerplate type of stuff that we don't want you to sort of implement by hand. Excuse me. And in the case of the GeoEvent processor base class, it takes a definition for its constructor. So whenever you use that base class, make sure you're passing in a definition to your class, or you know how to get to it from your constructor. In this case, we're passing it through the service, because the service is the one that sort of manages the definition. The service creates the processor and just passes it down. So now we're going to go to the initialization step. So that's, we have a method called after properties set. So the first thing that the service did is sort of took the configuration that the user had and set all the properties on it. And now we're going to call after properties on your class, and then you go and sort of read them using our built-in APIs to get the actual values out and initialize any members you need to initialize from those properties. So you can see here we have this get property method here that sort of knows how to get to the collection of properties that the service was set. And so now you don't have to worry about figuring out where all that stuff is stored. All right, and then once that's all done, it's good and done, we're going to call validate. So the one thing I want to point out here is the super.validate call. What super.validate does is make sure all of the values that are stored are the right types of things of, if something is supposed to be an int, it'll make sure it's an int. And things of that nature. And then we do our own little quick check to see if the GeoEvent definition name is actually set to something that's not empty. We could have done something where we went in and tried to see if it existed, but in this case that doesn't make, that's not required, because sometimes you configure a GeoEvent definition that is generated by another processor, so it may not actually be persisted at the time of initialization because events haven't flown yet, so it won't exist inside of the GeoEvent definition manager. And then finally, you're going to get the process call. So this one is very simple, right? It just sort of gets the GeoEvent definition. If I've got a handle to the manager, I'm going to look it up, and then I'm going to populate the GeoEvent with new entries, and I'm just going to return the augmented GeoEvent. All right, and these, all of the methods on this slide are actually optional. They're not implemented on the sample server, but I put them up there just for completeness. So there is some shutdown. We call a method on shutdown when the GeoEvent extension is shutting down. Oh, I need to update that. And on service start and on service stop. So shutdown is sort of the OS service is going away. All right, so GeoEvent itself is shutting down. On service start and service stop, those are when the user clicks start and stop in the GeoEvent manager. So GeoEvent's not necessarily going away, but the service that I was running in is going to shut down. And then this last one is the is GeoEvent mutator method. So for efficiency reasons, we try not to copy GeoEvents between different nodes. So it's a multi-threaded process that is processing all your events. So we try to pass the same event to everyone in a read-only capacity. But if you know your processor is going to modify that GeoEvent, change one of the fields, we ask you to implement this method and say return true, so that you get your own local copy of that GeoEvent, and then you can copy it and it doesn't affect anybody else. You have a question?
Is it better to copy and modify copy than modify the input? So you can use
It depends on if you want to, if you don't mind writing the code to copy it. It's probably the same level of efficiency as if the framework copied it for you. Yeah, the question was, is there a difference between copying it yourself or letting the framework copy it for you? It's just less code for you to write, right, if you don't have to copy it. And actually, the extent enricher that I demoed earlier today was actually, I think, makes a copy of itself, copies it by itself. But it's augmenting it anyway. So if possible, if you can make your not mutate, that'll improve performance, because now we don't have to make lots of copies. All right, let's go quickly through the blueprint screen. So just like Ming was talking about very quickly, here we've got, this top line right here shows that I want to use this interface. I want to ask for the reference to that service inside of the GeoEvent framework. All right, so I need that messaging service to run my service. So just give me a reference to it. I don't know who's creating it. This bean class, if you've ever done Spring, it's very similar. So bean, I'm just going to say, I want an instance of this class, and I'm going to set these two properties on it. And if you're going to extend the base classes that we offer you, you're going to include this second line right here, this bundle context line, because we do a lot of stuff with sort of OSGI to initialize stuff. So you'll want that. And then the very last line basically says, take this geometry extent enricher service bean, which I instantiated right there, and publish it as a service that implements that interface. And so as soon as you implement that interface and it's running inside of the GeoEvent framework, GeoEvent is notified, we get a handle to your object, and then we call the get the processor definition on it, and then your processor is now registered with GeoEvent, and it can be included in services. All right. So now the fun part. Let's see what happens, how you actually connect to this thing, so that you can troubleshoot and see what's going on. Let me see. All right. So first thing I want to point out is this file. It's called ArcGIS GeoEvent CFG. It exists under your installation directory. So if you go to your GeoEvent, there is an etc folder here, and it's usually the second line right here. So it's this line, and what you're going to do is you're going to scroll down until you find these two lines right here, and this is how they appear when you install the product untouched. You uncomment them, but then you add these two numbers right here, 17 and 18. So depending on what version you're running, these numbers will be different. I'm running 10.5.0, so at 10.5.0, the last parameter that came in for the JVM, to see these wrapper.java.additional, are the JVM parameters you want to have passed to the JRE. So this one stopped at 16. So I'm just going to continue going 17 and 18. Right, and I don't recommend touching these unless you want to change the way you attach to the debugger, and you're really smart about that stuff. But I just do the out-of-box stuff. And next, you need your IDE to support attaching to a remote Java process. So this is the configuration I've got for this guy. All right, so this is the extend enricher processor that I've got loaded inside the IDE. For networking reasons, on this JVM, I had to do 127.0.0.1 running on the JVM. I couldn't get it to attach from my Mac host. But in theory, you could connect to any server that you have network access to here. So you don't have to be running on the same machine as GeoEvent to do this. I wouldn't recommend you attach to a production server, but you could if you really wanted to. And then this 5005 port is just matches this socket right here. So if you change this, for whatever reason you can't attach to that port, you change that number here. And then now you just hit debug, and I believe the simulation is still running, so I hit a breakpoint right away. I'm inside of the process method. So now like if you're used to it, now you can just sort of step, and then just keep going. Function effect. All right. So that's all I wanted to show for this. Let me just, and then you can just disconnect, and then the process just keeps going. So that's something I always like to show developers, because I know we all like to attach to our code and step through. So just screenshots of what I did so that you don't have to take it on your phone and remember what we did. But yeah, that's the file right there that you want to open and modify. That's the settings I had it set to. And then once you do that and you restart the OS service, that's the one thing I forgot to mention while I was over there. You actually have to save that file, restart the Windows service, and then you'll be able to attach to the process. So once you do that, then you just sort of, you can mirror the settings that are on this screenshot, and you'll be able to attach to the running GeoEvent process. So now it's time to sort of summarize. So with GeoEvent, it allows you to develop and deploy custom processors so that you can extend the functionality that is available to you at the analysis phase. You're not limited to the out-of-the-box functionality. But do be very mindful that you have great power, and you can, if you're not careful, you can do very dangerous things inside of GeoEvent. And the Java geometry libraries are available to you when you're writing a processor. So the full Esri geometry libraries are in there. So you don't have to go bring some other geometry libraries to do whatever geometry operations you want to do. You can take advantage of the Esri stuff to do it for projections and whatnot. And finally, there's the link to the extent enricher that I was working with right now. So if you want to go play with it, there's other ones up there as well, but that's the one I was playing with in this section. And if you're interested in real-time and big data in the JS world, these are some of the talks that are still available for the rest of the week. You can go see Ming's IoT demo on Friday morning if you want. And then we have the applying real-time analytics. We have the IGEO analytics server as well. I'll be doing the real-time web apps with JavaScript on Friday at the demo theater. There's also some more spatial temporal data stores. I'll leave that up for one more second so people to see before I switch over. And then if you want to learn more, right, we have the links.esri.com/geoevent page, which sort of has tutorials, some introductions on connecting to real-time data, how to analyze real-time data, sending updates, how to extend GeoEvent server. And then we also have a forum. So if you do try to extend the processor or transport or an adapter, you can go on the forum. We'll try to answer that as quickly as possible. And then please, if you have the time, and you have the Esri event apps, just do some survey. Let us know what you like, what you didn't like, how we can make it better. For these talks, because I think this is now like the 4th or 5th year we've done this talk, so I hope we're not getting a little stale with the content. And then finally, we have questions. We now open the floor to questions for you guys. No? Yeah?
GeoEvent processors aren't cheap, so I want to have a dev environment. Devices and options.
I always tell people to talk to your account manager and have them see what they can do for you. I mean, off the record, I'll tell you different things. Any other questions? Okay, well, we'll be up here if anyone has more. Yeah.
What kinds of processors are customers writing? Do you find that? What do they need that you're just never going to do for them?
What's some of the more popular ones? A lot of people. Cursor on target for military operations. We have. Let me see if I can get to it. Somehow I made it so my Mac doesn't have internet, but my VM does. and I didn't want to touch it right before this is the demo, right before I went on stage. But like solutions, GeoEvent. But here's a GitHub project written by a guy at ESRI who works in defense solutions. So he wrote a bunch of stuff. So it's CapCut. So very industry specific type processors that aren't of general purpose use. So there's this, and then if you just come here to Esri and you look for GeoEvent, you'll see route monitor. Do we still support route monitor? Hadoop, Mongo, ActiveMQ. So a lot of transports.
If you look at the ESI gallery, you can see there we have something like water SCADA processor, water SCADA.
So here's the track idle detector that I was talking about earlier. There's a motion calculator.
Right. And there's something that's used for reverse geocoder processor.
That's all in your GitHub.
Yeah, they're on GitHub.
Right.
All right, thanks.
Right.
Any more questions? Okay. Well, thanks for coming. We'll be up here if you guys want to ask more.